For this question, we're going to be finding the integral of x to the power of half multiplied by 2x minus 5 all over 3 dx. So we are integrating this function with slices along the x direction. That's what dx means. When you look at this function, you might be tempted to see that there are two functions here, x to the power of a half and another one, 2x minus 5 in the brackets. When we have two functions, we are often directed to do the integration by parts. But in this case, I would like to say don't. It'll be far easier if we expand that function by multiplying the x to the power of a half with 2x and x to the power of a half with minus 5. First of all, I think I might want to get rid of this 3. So I will rewrite this as the integral, and I'll put the third at the front. I could move it before the integral sign, but I will keep it here. That means now I have x to the half, and I'm going to multiply this all by 2x minus 5 dx. Now I will expand this. That's the integral. A third times 2 will be 2/3. And if I multiply x to the half with x, I will get x to the 3 on 2. So I can write down x 3 on 2. Now I'm going to multiply it by minus 5. So that'll be 5 over 3. And just leave the x to the half. Okay, let's make sure that we put this in brackets, because the whole thing will be now integrated with respect to x. Now I can integrate this, so I will have 2 over 3 stays, but we will raise the power of x to 5 over 2, and we must now divide it by that new power underneath here, power over 2. We do the same thing over here. Leave 5 on 3, raise the x to the power of 3 on 2 by 1, and divide it by 3 on 2. Now, since we're integrating, we must do something really important here, and we must add the integration constant, which is c. If you do not do that, you will lose that mark. And there are 4 marks here, and the very first one is the one where you show that you can expand, and the second one is here for integrating and for the constant c. And the fourth one will be because you need to write each term in its simplest form. Now, when you're dividing fractions, then you can multiply them by inversing the denominator. So I'll show you. So 5 over 2 becomes 2 over 5. And we multiplied it by 2/3, follow it by x, 5 to the 2. And we do the same thing with these two fractions. Minus, switch 2 on 3, multiplied by 5 on 3. Leave the x, 3 to the 2, and add the constant. And this gives you 4 on 15, x to the 5 on 2, minus 10 on 9, times x to the 3 on 2, plus c. And that is our final answer. There are many examples in my playlist of applied integration, which you might want to have a look at. Also, I will be doing another video on integration by parts. So put thumbs up to my video and subscribe so that you can get notification of the next videos.